Thank you, everyone. Welcome to my talk, Message Redelivery, An Unexpected Journey. Just want to talk about message delivery is the core functionality of Pulsar, right? It's the basis for everything that makes Pulsar great, and everything is the fundamental basis for that. So this talk is going to dig into this process in a bit of greater detail, and then obviously focusing a bit on the redelivery mechanism. And I want to highlight some of the different configuration settings you have available to you to not only understand the behavior, but then how to control that behavior so it better performs in the ways that you want it to when you have message issues. So for those of you asking, who's this guy? Allow me to introduce myself a little bit. I'm proud to be a committer on the Apache Pulsar project, and I'm also the author of A Pulsar in Action by Manny Press. I've been involved with Apache Pulsar for half a decade now, and 3 times that in the big data streaming open source space here. As you can see from all these different logos, I've worked at several companies across many industries in my career, and generally struggle with keeping a job for any length of time. So let's talk a little bit about Pulsar. At its core, Pulsar is a client-server system. In Pulsar, the clients and the brokers coordinate with one another to implement the publication and consumption of messages. And both components are a critical part of this process, right? So the Pulsar client libraries play an equal part in making this process, some of these capabilities possible, that you lose if you try to do something with using HTTP to publish messages to Pulsar, or WebSockets or something like that. The inherent built-in part of the Pulsar clients is a critical part of this whole orchestration of message delivery and consumption. So let's start at a 10,000 foot level. I want to talk a little bit about how Pulsar clients and brokers interact with one another. As you know, Pulsar broker exposes 2 endpoints to its clients. The HTTP REST endpoint on port 8080 by default generally that has all the administrative tasks. And that generally goes to metadata manipulation inside your coordinator, inside your Zookeeper store. And then there's an endpoint traditionally on 6650 that's used for data transmission, and that uses what's called the Pulsar protocol, right? Different from the Kafka protocol or the MQTT protocol. It's our own unique client-server protocol. And command messages are sent back and forth over this communication channel to control the flow of data between the Pulsar clients and the Pulsar brokers. Now, there are, last I checked in the 2.11 version of Pulsar, there's a total of 67 different commands defined in the Pulsar protocol. All these different low-level commands that we send back and forth. These commands can be broken down into different categories, and I've highlighted the ones we're interested in here relative to message redelivery. There's the client commands. That's the first category, which is used by the Pulsar client class to perform basic tasks like establishing a connection, performing authentication, doing topic lookups that we just talked about in the previous section. Talk about doing topic lookups. That's a command at the low-level Pulsar protocol thing. You say, who's serving this topic to the broker, and it comes back with a response. Similarly, the consumer producer commands are all involved in the flow of data between the clients and the brokers. So let's look a little bit at the client commands here. Just these are all used again to perform basic tasks. They're not specific to any producer and consumer. And like most of the commands that we'll see, there's a pattern in the Pulsar protocol. There's generally pairs, right? There's a client command that's issued by the client, in this case like connect, and then a broker-based counterpart like connect did, right? So you send a connect response or command, you expect a connected response back if everything's well. Otherwise, you're going to get some sort of error messages. So these are in pairs, and we'll talk about how these handoffs occur, right? One has to get sent, and only after it comes back do we know that we're connected, right? So let's take the base case example and walk through this protocol, right? So for those of you who have interacted with a Pulsar broker before, the first thing you have to do is create a Pulsar client using something similar here. This is, again, the bare minimum. And all you have to do is specify the address, the broker endpoint we're trying to connect to on that 6650 port, right? So this is all you're telling it where to go and send this information. Now, as soon as you call that connect or that build command and do connect, under the covers, it sends that connect command over from the client to the broker on that specified URL, kind of like this shown here. So I apologize in advance, lots of UML diagrams in this chart to give a flow here. But this is the sequence of events that occurs. The connect command comes over, eventually gets to the broker. The broker does the authentication, make sure that everything's copacetic. It sends back a connected thing back to the client, and now the client is actually connected, and you know that you're actually successful. If something doesn't happen like that, and an exception is thrown, you get some of those connectivity issues, right? So that's the basics. Just talk about the command client and server model. So let's talk about message publication, right? So after you've created a Pulsar client object, the first step on a message's journey is publication. It has to be created first before it can be sent and eventually redelivered. In this section, I'm going to focus on how messages are sent, the publication process. So to do that, let's talk about the producer commands that we showed in the previous section. And these, again, are all used to have messages sent back and forth, right? So, for example, the producer success pair are used to connect a producer to a topic. And while Michael has all these send messages here, the send receipt, and send error, do the handshake in between the broker and client to indicate success or failure of the sending of the messages between the client and the broker. Now this code block should look familiar to anybody who's used a Pulsar client to publish messages. But under the covers, as I mentioned before, when you do this create method, you call that create. The first thing it does is send out that producer command to the Pulsar broker, and also sends along, so at this point you're authenticated, you have a role assigned to you, and you're also having a schema assigned to you. You send all that metadata over to the producer to trying to connect to that guy. And if everything's successful, you get a producer success command back. Now, as I mentioned before, there's a lot of different ways in the producer creation builder pattern. We have tons and tons of configuration model of properties. Here are some of the ones I want to focus on for message redelivery and how it controls the behavior of the producer, the redelivery of the messages, how long they're kept, how long the batches are controlled, things like that. So these are the ones that are very specific to you. I won't read all those information for you, but these are the ones we're going to highlight during this talk. So again, this is the producer creation flow. Now this is before, again, you're on the Pulsar client, you say new producer, you send the producer command over to the broker, it authorizes you, and you get a producer success back to indicate success. But as a result of this process, there are actually two producer objects created. The one that you're dealing with on the client side that you're all familiar with and you're going to interact with, but there's also a corresponding producer created on the broker side as well that handles handling all the message publication parts. Right, so the parts that you may not know about is this broker, or this producer here in this particular broker package. I won't get into it, won't read that to you. But it exists on the broker side, and it retains a reference to the corresponding topic, right? So inside the broker, there's a map of all the different producers that are being active on that particular broker at that point in time, and it keeps a reference to the topic. And the topic is in turn responsible for writing all the received messages to the managed ledger, doing the managed ledger rollover, persisting the data onto Bookkeeper in case of a persistent topic, and handles all that. So there's a handoff step that happens on that side. On the client side, obviously, that's the one that we're all a little more familiar with. And the object I want to highlight inside of all these internal data structures is this batch message container object, right? And that is used to retain these messages until batch is considered full. So every time a message is published using that send command or send async, instead of being sent right over the wire right away, they're stored in this batch message container. And when the batch is full, the messages are removed from that container. Well, they're sent over the wire, obviously, but they're also moved concurrently to what's called a pending messages queue to await acknowledgement back from the broker that they were sent and successfully received and are persisted to disk. Right, so this is the basic workflow. You've created a producer. You can call as many times as you want to send message over that producer object, and inside it's adding it to this message container. Now eventually that batch gets triggered, right? And the triggering of this batch is controlled by those various settings I showed you previously with all those batch max properties, right? Either batching max bytes, messages, or publish latency, right? So you can specify, I want it to get this many bytes or this many messages, or from the time the first message was published until the last time, which is your publish latency, whichever one of those events occur based on time, that considers the batch full, and then that's what triggers the sending of the messages over. Right, so this is what we're talking about here. Once it's full, this is a little bit getting down into the flow chart of what happens. They're sent over. These raw messages, which are just the raw bytes you've had, and maybe the keys, and maybe the properties you've attached to them, are also prepared by enriched with some metadata as well. And this happens naturally inside that particular method shown here that create ops send messages, right? We annotate with the producer name, the sequence ID, creation time, all this different tagging and metadata, and send it over well. And this is critical for the Pulsar message deduplication and redelivery mechanisms, right? This is some additional metadata you get for free, and it occurs in this particular step once the batch is triggered. We have all this information, and we're going to keep it in the pending messages as well because we want it annotated once. We don't want to re-annotate these same messages in the redelivery process. We're going to resend the annotated messages going forward. Right, so eventually you have this information. We go through all these messages, and again, as I mentioned before, we add them to this pending messages internal queue inside on the producer side, on the client side producer. So it's just a buffer of all these messages, and it's a way of tracking. It's a bookkeeping of, I hate to use the term bookkeeping as a bookkeeper, but we're keeping track of what messages we sent, and we expect a response back. And then subsequently, we send these over the wire to the broker. in a batch. So it's an entire batch, and they get sent as an entire batch and stored as a batch. And now on the broker side, once a message, the receipt of the send on the broker side leads to the publication of the message data to a bookkeeper here. And in this scenario, we can see that bookkeeper was able to achieve the specified ACK quorum that we dictated, and which indicates a successful persistence of the message batch. And so in this case, everything is copacetic. We send a send receipt back to the producer, and when he gets it, he can remove it from the pending message queue. It's one less message down. It's not in flight. It's been accounted for. It's been ACKed, everything like this. So it's good to go. And this is the happy path, and 99.9% of the time, this is what happens. But there's an opportunity for message redelivery in this case, right? So the first one is if the message cannot be persisted, right? So in this scenario, for whatever reason, we weren't able to achieve an ACK quorum. Bookkeeper was down, a network issue, something like that. Maybe bookkeeper, all the disks were full, they're in read-only mode, something like that. In this case, to indicate failure, the producer on the broker side sends back a send error command to let the client side know, hey, something's going on with this particular message, and I can't send it right now, right? So if and when the producer on the client side, again indicated in red, receives that send error message, it's highly likely that the issue on the broker has impacted multiple messages, right? So at this point, we're probably just gonna proactively resend all the messages in the pending message queue immediately. That's the behavior inside Pulsar right now. So if we get a send error inside the handle send error method, inside that client-side producer chain, we just basically trigger off, say, go grab all the pending messages we haven't gotten a receive for, send them again. Right? So that's scenario number one. Now, scenario number two, the possibility of message redelivery is also in the case where the producer is unable to transmit the message in the first place, right? It was back in this original loop where we thought we're ready to go, right? The batch has been triggered, we've added them to the pending message queue, and we try to send them, and there's a network issue. Maybe on our side, we can't connect to the broker. We connected to a broker that was getting rebalanced, and so while we're trying to send it to broker A, it's shutting down and it's not serving that topic anymore. And so that, either way, these messages are gonna remain in the pending message queue because we're never gonna get a send receipt back, right? We're not gonna get a send error either to indicate that there was a failure, but it's just gonna be the absence of anything. We sent it out and nothing really happened, right? We sent it over the wire, we never heard back from you. So what do we do in this scenario, right? This is typically, if the client-side producer is alive, if it is something that we still have the messages still exist in memory, it will when it attempts to reestablish a connection. So let's walk through the broker reassignment scenario or temporary network transaction transient error, again, because the clients automatically try to reconnect to reestablish the network connection, right? So eventually, let's say it eventually succeeds. And the first thing it does when it reconnects is to send all the messages again in that loop, right? So once the connection is opened, it has this method inside the code that calls resend messages, and it does exactly what's said. And it takes all the messages out of the pending message queue, which again have already been annotated with the metadata, so we're not gonna arbitrarily change the send time or arbitrarily change any sort of producer sequence ID. It's gonna be the exact same messages again and sent back over the wire to the broker, right? And then on that side, if we did send it, the scenario was that we sent it, but the broker wasn't able to respond, then message deduplication will handle that again because the producer name and the sequence ID will be identical, and it'll be identified as a duplicate on the consumer side. So that's all the message producing side. So after we publish messages to Pulsar, the next step is consumption. So let's talk about that a little bit. All right, so similarly, there's a suite of commands on the consumer side shown here that are used for consumption of data. The subscribe command is used to connect a consumer to a topic, and while the flow command, the next one in that sequence, handles the automatic retrieval of the data, the prefetching of the data to bring in the data to the client to make it available for you. This basically, the consumer under the covers uses a pull-based model where the consumer requests additional messages to be prefetched, and the messages are sent into the queue and then they're served from there. So again, this is a similar code block. It's the very basics of anybody who's used Pulsar client on a consumer side. And under the covers, when you call the subscribe method, under the using the Pulsar protocol, a subscribe command is sent out along with all the different topic name and your schema information, all that sort of thing. And if you have permissions, you're authorized, you're using the right schema type, a compatible schema, then a success command is sent back to you to indicate that I'm connected and now I can consume messages. These slides will be available later, but I just wanted to highlight these are some of the ones on the consumer creation configuration properties you have that can control the redelivery mechanism of the process, right? And here being the acknowledgement group time and the Ack timeouts and negative Ack redelivery delay and things like that as well. These are all knobs that you have to control the message redelivery process, assuming things go wrong, right? But let's start with the basic one, the happy case, right? So you've created a new consumer, you send the first subscribe command, you're authorized, it comes back, success comes back, everything's happy. Now you again. Likewise, you have two consumer objects created as well. You have one on the client side, and you have a similar one on the broker side, just like in the producer. So again, it's a pattern, it's a pair that exists on both sides, and they coordinate with one another to get the job done. Again, I apologize for throwing UML at you guys, but it's the only way I can really dictate these things. This is the broker side consumer object, and it's really attached to a subscription. And a subscription can have multiple consumers, and the subscription uses the message dispatcher, which is why you can throttle and control the number of messages sent out over for any particular consumer on a particular batch, but you can't do it in aggregate. It's just limited to one particular consumer. It also keeps a pending Acks hash map, and the message dispatcher ultimately, interacts with the message cursor to figure out where to read the data from the disk in Bookkeeper. So that's how it accesses the managed cursor. This is the client side one. I won't go into all these different details, but you have a consumer object that has an income messaging queue, which is a blocking queue of all the messages that get pulled in from the flow command. They get stored there. All the receive messages pull. Every time you call receive, it pulls them off of this queue as well. We also have a couple different tracker classes here as shown here, right? So there's a negative Acks tracker we'll talk about, and an unacked message redelivery tracker. Both of these things obviously track the messages for redelivery, negative acknowledgement, and we'll get into that in a minute. So let's talk about the message delivery process, getting it from point A to point B. Right, so as I mentioned before, it's a pull-based model, and when you first consumer first subscribe, you send a flow, and you send it all your available permits, what's called the available permits. For those of you doing, doing debugging and you're looking at the stats, the available permits is kind of one of those telltale signs. Is it a big number? Is it a -1? Have I consumed all the messages on my consumer side or not? But it says fill up the queue. I got 1,000 slots for messages. Send me all of them. The consumer gets it. It calls a subscription, and the subscription decides to send those messages back, right? Now, the messages are chosen by the subscription on the broker side and read from Bookkeeper, right? Because again, based on what subscription type you're using, shared, key shared, exclusive, it could be different messages, right? So it delegates that decision to the subscription object, which in turn, once it's decided, it sends off to the dispatcher, who can apply any throttling you have, policies based on namespace, topic, that sort of level to say, okay, you requested 1,000 messages, am I allowed to send them? And if so, then it automatically will update that managed ledger in your subscription information and go and get that information from Bookkeeper and send those entries out. Right, and this process continues over and over again, and once it gets these messages back, it sends them over individually, send message one at a time, but it opens a channel. It just opens up a point-to-point channel and sends these messages individually. But that's fine, all those messages get sent back to you, and they get added to the incoming messages queue. We're using an offer command there because it's a blocking queue, so we don't interact with somebody who's reading simultaneously, but eventually adds all those messages back to your queue and it keeps it full. And this process happens over and over again automatically. Right, so when you consume messages on your consumer side, when you actually say receive in your code, application code, you say consumer.receive, you're actually pulling messages off that incoming message queue. You're doing a take, you get the message back, you have it, and you can do whatever you want with that message. And this is the intermediary buffer between the broker and the client itself. Right, so periodically, again, the client side consumer, as the messages are removed from that incoming message queue, we check to see if we need to initiate the flow of more messages from the broker, right? So we try to proactively fetch these messages so we're never blocked waiting for messages to arrive. So typically every time a message is taken, we check to see how many available permits, and if it's below, if we're less than 50%, if we're 50% or more empty, then we say, okay, it's time to request more messages, so the next flow will come out and we'll request the next 500 messages because we're trying to prefetch the data so we're never blocking on that side, right? Just wanted to fill that out. So you've got the message, you've pulled it off the queue, you did receive, you got a message and you're done with it. You have 3 different options, obviously, you can think of that you could natively do. What's technically 4, you can just ignore, choose to do nothing. But these are if you're actually trying to do something. You can acknowledge the message, negative acknowledgement, or you can say reconsume later, sort of thing, right? So let's talk about the message acknowledge path, right? This is the basic successful, happy path we got on. I got the message, I did a receive, I did my processing, everything was happy, everything worked fine. Now I want to send an acknowledgement to say I don't want this message ever again, right? So this is to indicate it's been successfully consumed. Now the behavior of how this process works is controlled by these particular properties in the consumer builder here. So it's an acknowledgement grouping time, your Ack timeouts, your redeliveries, and your tick time here. And these are the 4 properties we'll talk about a little bit and how it impacts message redelivery. So the first one is if you set this time property to true, then the Acks will be grouped together at a specified interval. So if you don't set it, you consume the message, you Ack them as soon as you send the Ack over the wire every single time, so you can have lots of message data, lots of network stuff coming in to the broker in every individual message. If you want to batch them up for higher throughput, you can say wait every 1 second, 5 seconds, 10 seconds, and send them all in one particular batch, right? Either way, they're eventually sent over the wire like this. But that's your first option you can control in that behavior. Now on the broker side, this Ack is received and it's removed from the pendings Ack list. So again, we sent them out earlier, so these are the messages we have. Come out and the subscription updates the cursor position, and an Ack response command is sent back to complete the handshake, right? So you've acknowledged the message. We do the bookkeeping on our side to say, okay, we're not going to send this in a redelivery scenario, and at the same time we're updating that information, and the removal of the Ack from the pendings Acks list is critical, as any messages contained in this list will be redelivered if the client reconnects and sends back a command asking for all the unacked messages, right? So we've got to make sure we clean that up. So, in the previous section, we saw that the client side consumer acks the message and it expects to receive an Ack response command back from the broker side. Now, this Ack response indicates the subscription cursor is moved. In this section, we're going to discuss what happens if the client side consumer doesn't get this Ack back, right? What do we do in the scenario and how we're going to have to redeliver these messages, right? So, the waiting is it's basically step 1. I've sent out the messages out, I've had these Acks, and I've sent them out, and I'm waiting for the broker to come back, so we have to wait. On the client side, all these messages that we sent out, when we sent them, we've added to the UnackedMessageTracker and tracks the receipt of these Ack commands back one at a time that were sent out, right? So it says, you start out, you send them, you fill it up, these are all the messages I sent, and as an Ack response comes back, you knock them off one by one message to say, this is my list of messages that I've received, and so whatever's left is what you've sent but not received an acknowledgement back. These are the ones that have to be redelivered because you don't know the state of them at all, and so you're going to have to request these messages back. Now, how long the clients decide to wait for these Ack responses is referred to as the Ack timeout collectively. This is how long I'm going to wait before I decide to take action. Now, again, messages are added to this UnackedMessageTracker as we send them. Again, so if you set the grouping tracker time, they'll be bundled up there. When you add these acknowledgments in, when you do an Ack, they get added. Eventually, whatever your timer is, whether it's 0 and it's triggered immediately or after a certain amount of time, it gets sent and they get added to this UnackedMessageTracker, and the Ack goes out over the wire to the broker. Right, to ensure that we only redeliver messages that have not been Acked, we remove the messages as they come back. So again, an Ack response comes back. In our handle Ack response code block and on the consumer side, on the client side, as part of that processing, we remove it from the UnackedMessageTracker, so we have an accurate record of what's been sent and what's been acknowledged back. Now, any messages that remain in this UnackedMessageTracker after the Ack timeout can be handled in one of 3 ways, and this is the gory code. I thought it was just better to take a snapshot of the low-level code here. And there's different options, right? The first option is to completely ignore the lack of response, and then you can do this by setting your Ack time to 0. So the if block here is if it's not equal to 0, you do some stuff. If it's 0, you just set it to the disabled, right? UnackedMessageTracker disabled. You don't care. You're tracking these things. Nothing's happening. You don't care. The other 2 are just different variations of the same thing. We'll talk about a little bit, but you can have these different ones that are timer based, right? And so these timer based ones are controlled by this Ack timeout property, right? So if you set the Ack timeout property to 0, then there's Ack tracking is disabled, and this is the same as it most wants processing, right? You're gonna get it over, it's gonna move it on the other broker side. It's gonna assume you got it, update the cursor. It doesn't care. You're not waiting for a response back. Otherwise, based on your configuration settings, you're doing a timer-based redelivery of these messages, right? And so the only difference between the 2 implementations is how this interval is calculated. Now the first one, this base one, is basically set, it's in a fixed interval, right? And it is controlled by the Ack Timeout property by default. So if you say my Ack Timeout is 30 seconds, it's going to do it every 30 seconds. It's going to, that's the expiration from the time I sent the message until I wait 30 seconds. I will wait that long until I send back a message to the broker saying I want this message again. But you can override that with an Ack Timeout tick property if you want to set it to 2 minutes instead, and you have a different variable. You can do that sort of thing. The other option is you can have a variable interval based on the value of an Ack redelivery property, so you can implement more complex back-off policies like this one shown here. We can have an exponential back-off, for example. If if you anticipate that it might be because of network traffic on the broker side, the Acks aren't coming back, bombarding the thing every 30 seconds, asking it for an Ack back when it's already busy isn't a good idea. So you can sort of have an exponential back-off policy here, and this is another example of setting that up. But either way, they're both based on a timer object, and there's like a netty timer object internally, right? And the UnackedMessageTrackers both use these ones, and just that variable when it is triggered is all that changes in those calculations. But once that timer object is up, it triggers the sending of this redeliver unacknowledged messages over command to the broker, and it specifies the messages itself, right? This is the key. It says, hey, I've got these message ID. I haven't heard about these. Can you tell me what's going on? Have you got these guys or not? And it sends this over to the broker, right? Now, on the broker side, when he gets this one back, he's going to resend all those messages in the pending Acks, or he's going to take those message IDs that were specified, verify that they were in the pending Acks, take those out and send those ones over individually. So surgically resend those ones that he's asked. So this is your message redelivery based on Ack Timeout, and that's controlled by that redeliver unacknowledged messages. So we've got about 4 minutes left, so I'm going to try and go fast here like Pulsar. Now let's look at message redelivery and how it works for negative. So these are the ones we explicitly said, hey, I don't want this one. This is the unsuccessful processing, but you want to do it again, right? So if you never, again, these are added to your negative Acks tracker. There's a corresponding, there's an unacked and there's a negative Ack. So again, there's a pattern here. If you explicitly negatively acknowledge it, we add it to this tracker, and we keep track of that information, right? Similarly, it uses, there's only one variation that uses a timer task to trigger the redelivery of these ones, and that's controlled by the negative Ack redelivery property. I believe, I didn't confirm the code, but I think if I could set this to 0, then it won't be redelivered at all. They just never get redelivered. But if you set this one here, then you can specify, how long you wait before the negatively acknowledged messages get sent back. So it's a very similar pattern. Again, here, once that timer goes off, it triggers the redelivery. It sends the exact same message over, redeliver unacknowledged messages. But again, this time it's taking the message IDs out of your negatively acked messages tracker, right? So you can say, I want to send these, give me these particular messages, send them again. So it's just controlled by that one property. Once that time is up, that's how long I'm going to wait for these negative acknowledged messages. It'll buffer them and wait to get this information back using this protocol. So it's a very similar pattern throughout the code. One last thing, waiting, redelivery. Yep, timing's right, we're getting close, 2-minute warning. But sometimes a consumer might receive a message that's not quite ready to process yet due to the need for like another service or to complete a task, or maybe a database table to update or something. You get a thing come in, you're doing a race condition, you have a key in the message, and you do a database lookup table and it's not there, and you want to go through this whole 30-second delay Ack delivery. There's another scenario as well. You can do something else as well. You can do what's called delayed message delivery in this scenario, right? Now, for this capability to work, the enable retry property must be set to true. That's one I showed you at the beginning. It's a true or false. If you don't have this, it's not going to work. Now, from an implementation perspective, this redelivery is accomplished by creating a new producer class that under the covers handles the publication of this messages back to the consumer's topic. This ensures that the data isn't lost in the event of a crash, right? So we're not holding it in memory somewhere. We immediately, if you say, I want this delayed memory here, so you say consumer.reconsume later, the message, and you specify 3 seconds, we're still going to put it somewhere to disk on a topic. So if something happens in those 3 seconds, that message isn't lost forever, and we don't know what happened, right? So under the covers, again, we just, once you call consumer, it goes to this producer object and uses the deliver after feature of the producer object to make sure that this message gets delivered, right? So this is shown here. When you call reconsume later method on the consumer, this is just a snapshot from the code. A producer object is initialized using the following code block. This is directly from the 2.11 code. You can see it copies over the schema, batching is disabled, blocking is enabled, and you can see here that it takes the dead letter policy, retry letter topic as the target of where it's going to publish these messages. So if you want it to go in a loop and go back to that same topic, send it back to yourself. If you want it to go somewhere else, you can control where these messages, these reconsumed later messages get routed to based on that specific property there. So once that's done, the redelivery behavior in this scenario is limited to a maximum number of attempts. We don't want this going on forever, right? So it comes through the code, you look up, hey, didn't have this message yet. I want to send it again and again. So we want to prevent this from being done repeatedly. We have a custom system property here. We annotate it every time we send it in there. We take it out, we increment it, we put it back in there. So it's attached to the property. Once it exceeds that max redelivery count setting, it gets sent to the DL queue instead. So we might try 5 times on that. Otherwise, we're just going to keep trying to send it over and over again. So it could be tried like 3 or 4 times on that. So key takeaways. I know we're getting itchy there. Real close. Time's up. Today I discussed message publication and consumption of Apache Pulsar, highlighting some of the various redelivery scenarios. I just talked about how it uses commands within its protocol to control the flow of messages and track messages back and forth. And it's critical that both the clients and the producers perform this handshaking, right? They send the data over, they have a way to communicate success and failure, and they keep a message track of each one. And I talked a little bit about how you can control this behavior by some of the different properties on that. But when these handshakes fail, the redelivery process is triggered to ensure that no data is lost. And with that, I will thank you. Hopefully you enjoyed my talk, and please follow me on Twitter, read my blog posts, everything else. Thank you very much. And I'll stop talking.